Okay, this is lesson 10.5. This is your last lesson of chapter 10. And this is graphing square root functions. So remember, functions follow some certain patterns that we've talked about. And that's that for whatever x value you have, you can only have one matching y value for it. You can have repeating y's, can't have repeating x's. So example 1 is just looking at domain and range of these. So there's some rules that we're going to talk about so you can kind of see the limitations. So this says find the domain and range. We're going to look at a couple of them. So the first one is y equals the square root of x plus 3. Okay. So you really have to think about what you understand about square roots and what you understand about the math from this year in order to really think about your domain and your range of these. Stop and think about what you already know you're not allowed to have in the square root here. You should have realized not allowed to have negative. It's not about this just being 0 every time here. What you're trying to think of is what's going to make this whole square root become 0, because you can't go below 0. So all you're going to do is take what's under the square root, and this is mental math a lot of the time, but it's better if you practice it when it's not mental math so that you know how to do it even when it's not. So when you go to find domain, all you're going to do is look at what's under the square root, and you're going to think that the lowest that could go to is 0 before it becomes negatives. So you set it equal to 0 and you solve. In this case, negative 3. Negative 3 is the lowest that our range or our domain can be. X's can't go below negative 3 because as long as you have below a negative 3, then you have a negative under your square root. Notice if we were to plug in a negative 4 there. Negative 4 plus 3 is negative 1. But negative 3 plus 3 is 0, and the square root of 0 is 0. 2 plus 3, or negative 2 plus 3, negative 1 plus 3, 0 plus 3, all those numbers work. We just can't go below negative 3. So now you have to think about, I just gave you a bunch of numbers that were greater than or equal to negative 3 that did work. These all worked. So you need to write this as all possible x values, which means we're going to do one of these that you've seen before. X such that we know that x is what than negative 3. It was all greater than or equal to negative 3 to keep that positive. Okay, now your range is going to be really easy to figure out because your range is based on if there's anything on the outside of the square root over here. If we had some number adding or subtracting to that square root or multiplying or dividing, then we'd be talking about our range. But in this case, we don't. So it's really easy because it's just like a plus 0 here. Negative 3 goes in, this becomes 0, I have 0. So my range is that all my y's are just going to go up from 0 because I'm never going to go below that. I'm going to have 0, I'm going to have 1 plus 3, which is 4. I'm going to have all these other numbers, but nothing's ever going to be lower than 0 here. So y such that y has to be greater than or equal to 0. And you'll see an example of another one of these in a minute that might help you see that a little better. Okay, let's do another one. So again, kind of compare it to this first one. Y equals the square root of 2x subtracting 8 minus 3. So this minus 3 is on the outside. That's going to change the range. Remember, here I want this to be 0. So I'm going to set that equal to 0, and I'm going to solve for it. And I'll know what I can plug in here that's going to give me 0, the lowest I want to go. Now, once you have square root of 0, your range is based on this whole this whole function. Square root of 0 minus 3 is negative 3. So the lowest that your graph is ever going to go on the y-axis is negative 3. So you already have your range right there. So you know that all your y's have to be greater than or equal to negative 3. So this right here tells you your range, because that's going to be 0 anyway at the lowest point. It's never going to go below 0. Now your domain, you just take 2x subtracting 8 and set it equal to 0 and find what it is. So I'm going to add 8. 2x equals 8, divide by 2, and I get x equals 4. So 4 is the lowest number I can plug in there to get 0 here. 4 times 2 minus 8 is 0. All my x values have to be greater than or equal to 4 in order to be true here, to be real number solutions. So I'm going to write x such that x has to be greater than or equal to 4. Okay, so we're going to write that in, what we just talked about. When you go to graph, you're going to use a t-chart. Right now we're just talking about domain and range though. So when they ask you about domain, remember domain deals with possible x values. And when you're looking for domain, you're going to set the radicand, which is the part under the square root, under square root, equal to 0, and solve for the lowest possible value of x. And you're going to write the domain as an inequality. And it says if needed, because sometimes you might come across something that you end up with only a few possible solutions, which I don't think we're going to come across today. Okay, the range was all your possible y values. So remember, on the first example, when you have no value outside the square root, then the range is always y is greater than or equal to 0. Every time there's nothing on the outside. When you have values outside the square root, the range changes. So you just have to be aware of that. And we'll try some of these tomorrow, because these are a little bit difficult till you've done a few. And then once you've done some of them, you'll start to see the patterns. Okay, now we're going to start graphing them. So example 2 says to graph f of x equals the square root of x plus 4. Okay, you guys all know f of x is equal to what? You should know by now f of x means y. So you're just going to set up a t-chart, or a table if that's what you call it. And here's the key. It's kind of like finding a vertex for the quadratics when we were graphing the parabolas. It's almost exactly the same. The deal is that you have to find that lowest point or highest point of the graph on the domain. You're going to need to find that. And so your first point is always the lowest domain. So you're always going to find your domain first. Okay, so what I mean here is I'm just going to look at domain. And remember, we just learned to find domain, part under the square root, set equal to 0. Because that's the lowest that square root can go. And I notice it's negative 4. Does everyone see that? So I know my domain is the x such that all my x's have to be greater than or equal to negative 4. If any x's went below negative 4, I'd have a negative under here. It wouldn't be true. So that becomes the first point, the first x value for my t-chart. So I plug in negative 4 first. And notice when you plug in negative 4, because we had no value here, we get square root of 0, which is 0. Okay, that just gave you your range. It's almost exactly like those quadratics. Domain is based on here. We found the domain. Range is based on this right here. So now we know all the y values are only going to go up from 0. And they're going to go up because that's positive in front of that square root. Same rules are applying. So give yourself a little note right here. This is my range. Okay, that's starting my range right there. So now I just get to pick anything I want, but it needs to be greater than or equal to negative 4. It can't be less than negative 4. I can pick negative 3. So square root of negative 3 plus 4 is square root of 1, and the square root of 1 is 1. I can pick negative 2, but watch what happens. I have negative 2 plus 4, which is the square root of 2. I don't know the square root of 2. It's not a perfect square. I can type it into my calculator and I can estimate it. But what I'm going to go ahead and do, because I know other numbers that are going to give me perfect squares here, is I'm just going to cross that out. I'm not even going to worry about it. And I'm just going to look at the next value that would give me plus 4 here, that would give me a perfect square. I already got 1. I already got 0. So, oh no, I didn't get 0. I didn't plug in 0. 0 for x plus 4, so 0 works. Because if I plug in 0, I get the square root of 4 and the square root of 4 is 2. So now I'm going to look at the next perfect square. 5 isn't a perfect square, 6 isn't a perfect square, 7, no, 8, no, 9. 9 is a perfect square. So 4 plus what gives me 9? It was 5. So now I can plug in 5, and I get 5 plus 4, which is the square root of 9, and the square root of 9 is 3. So now I have 4 points. 4 points should be enough to give me a pretty good idea of what my graph is going to look like. So remember, now I know my range from over here, so I can actually write in my range was y such that all my y's end up greater than or equal to 0. And if you notice, that was the lowest, and these are all greater than or equal to 0. So now I'm going to draw my graph. That's not the best graph. Hopefully yours is much straighter than mine. And I didn't go back far enough. Okay. So now I'm going to plot the points. So I have -4, 0 was my first point, my lowest on my domain and my lowest on my range, which means my points can only go this way and up. -3, 1, 0, 2, 5, 3. Okay, so let's go over this one more time to make sure we understand everything. You're going to set up a t-chart just like you did with any other graphing. When we graphed lines, we did when we graphed absolute value, when we graphed quadratics. You're going to get the domain and the range from that first point again that you're going to graph. And that's going to be your furthest over one way or the other point and your lowest or highest point, depending on how it opens. So it's almost like a vertex. Your domain you find by taking what's under the absolute value, setting that equal to 0. Whatever that makes equal to 0, that is your domain. All your numbers are either going to be greater than or equal to that, because you have to make sure you don't have negatives under your square root there. Once you plug that domain number in for x, you're going to find the y that matches it, which in this case is 0. Whenever you have just a square root here with no plus or minus or times anything else there, you're always going to have 0 for the y there. So your range is y's all are going to be greater than or equal to 0. You have no y values below 0 on the y-axis. So that's a recap on that. Once you have that, you just plug in some other points for x. You know that you're not going to plug in anything lower because you're not going to get an answer. If you were to plug in -5 for x here, you would have a negative in your square root, and it wouldn't be able to be graphed on here. So you just want to pick points that are going to be true from that point on. And once you have some, you should get a shape that looks like this. It's almost like half of a sideways parabola. So remember that your first point is always the lowest point and also the furthest point on the x-axis. And so we're going to go ahead and write a little more here. So first point, you're going to find the domain and use that value. To find the range. And that'll always be that first point that you plot that goes with it. Okay, then from there, you're just going to choose other x values that are easy to evaluate with, and that give real number solutions. And what I mean by values that are easy to evaluate with are things that are going to give you perfect squares. Something that's going to give you a perfect square is going to be a lot easier to graph than having to plug it into your calculator or estimate where it would be. So you always want to look for values that are going to give perfect squares. So you want perfect squares that are going to be easy to simplify. Okay, let's try another example. Okay, this is example 2b. Just going to do another one so you can see what happens with different versions of these. So graph f of x equals the square root of x plus 1. So it's really important that you always keep your square root over only what you want to be under the square root. So if this plus 1 was under the square root, I'd have to make sure that square root went all the way over. But only the square root of x is under the square root, and then plus 1. So watch for the pattern of what happens with our domain and with our range when we have this. So remember, first thing you always want to do is find domain. And the way that you find domain is you set what's under your square root equal to 0 and you solve for it. So this one's really easy because what's under the square root is just x, so x equals 0. So our domain is that all numbers have to be greater than or equal to 0. If we were to pick any numbers less than or equal to 0, well, less than 0, we would end up with negatives under the square root, which we can't have. So our domain is x such that all x values have to be greater than or equal to 0. So now you set up your t-chart, plug in 0 right there for your first x value. And when you plug in 0, then you go solve to find your range. So when x equals 0, and the only reason I'm doing x equals 0 is because that was my domain value. If this had been another value, I'd have a different number there. F of x equals the square root of 0 plus 1, so f of x equals 1. So your first point that you're going to graph is 0, 1. And your range is y such that all your y's, in this case, I'm going to have you wait and see the pattern just so that you see, but they're going to be something in relation to 1. So now I'm just going to pick any values greater than or equal to 0. I already chose 0, so I'm going to pick other values. Remember, you want things that are perfect squares, like 1 would be really easy to plug in here. So now I go and I solve for it, and so I can just go over here, plug in 1, so the square root of 1 plus 1, square root of 1 is 1, so 1 plus 1 is 2. 2. Okay, pick another square root value. 4. Square root of 4 plus 1, so the square root of 4 is 2. 2 plus 1 is 3. And then pick one more, so 9. The square root of 9 plus 1, square root of 9 is 3, 3 plus 1 is 4. So what's happening with your y values? They're all going bigger, so everything is going to be greater than or equal to 1, right there. So now set up your graph. So we have 0, 1, 1, 2, 4, 3, and 9, 4. So in this case, your graph's moved up 1 on the y-axis and then still opens pretty similar to the last graph. But this plus 1 right here moved it up 1. So if it had been minus 1, what would have happened? That's right, it would have moved it down 1. If it had been plus 4, it would have moved it up 4 and started at 4 up. If it had been minus 4, it would have moved down 4 and gone over. Remember, it's okay to have negatives. It's not okay to have a negative under the square root as a final answer. But you can still have negative values sometimes, depending on what happens outside of the square root. Okay, this is the last example. This is example 3. And it's actually just talking about looking at a real-life application. It's talking about when accidents happen. And so when there's a car accident, police actually have a formula that they use to try to find out the speed of the car, and it's based on the length of skid marks. So that formula is the police use R equals 2 times the square root of 5L, and R is approximately the speed of the car, and L is the skid marks in feet. Okay, so police will use this when they're investigating an accident to find out if someone was speeding, or, you know, try to figure out what happened in the accident. So again, if you wanted to look at a chart that showed all the different ranges of the length of a skid mark versus the speed of a car, you could show that on a graph. And you would graph that the same way that you would graph these other graphs. So what's the first thing you're going to find? That's right, you're going to find your domain. So you go ahead and look for domain. And remember, domain is everything under the square root setting equal to 0. So 5L equals 0, and when I divide by 5, I get L equals 0. So in this case, I know that my skid mark lengths are all going to be greater than or equal to 0, which makes sense because we're not going to have a negative skid mark length. Once you take that 0 and plug it in, you're going to solve for your range. And if you notice, in this case, we have 2 times the square root of 5 times 0, which ends up being 2 times 0, which is also 0. So our range is also all speeds of the cars basically have to be going greater than or equal to 0 to produce any skid mark. Now there are cars that end up driving and they're going the speed and they aren't going 0 miles per hour, but we're talking about in relationship to skid marks. And a car that's going 0 miles an hour is going to make no skid mark if they were to slam on the brakes. Okay, so now let's go ahead from here, set up our t-chart, and look at our graph. So I'm going to go ahead and put the t-chart right here. And we already have our first point. It's 0, 0, domain and range. Now you're going to pick real life x values, which would be anything. Now you want to look again, what's going to give me a perfect square here? So I want to look for numbers that are going to be easy. You don't want to use a number like 1 or 2 or 3 because you're not going to get a perfect square. So I'm looking at a number like 5. Because now I have 5 times 5, which is 25. So I have 2 times the square root of 5 times 5. 5 times 5 is 25. The square root of 25 is 5. 5 times 2 is 10. Okay, I'm going to look for another number like that. So I'm just going to start looking. So 6 times 5 is 30. 7 times 5, 35. So none of this is working. 40. And I'm just going to go through until I get to another perfect square. And I actually don't find another perfect square that I'm thinking of until I multiply 5 times 20. When I multiply 5 times 20, I get 100. So now I have 2 times the square root of 5 times 20. The square root of 100 is 10. 10 times 2 is 20. I end up getting a 20, 20 there. I could keep going if I wanted, but at this point I think because this is so far along on my graph, I'm going to have a pretty big graph anyway. So I'm just going to go ahead and graph that and make sure I've got a pretty decent looking graph. So remember those points. Hopefully you have room on your paper. I'm going to turn my paper. And when I set up my graph, I know I'm dealing with real life, so I'm going to have the first quadrant, because I'm not going to have negative values there. And I need to remember I'm going all the way to 20. And I'm going to go ahead and go with 2, 4, 6, 8, 10. I'm going to go by threes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I know I'm trying to get to 20, 20 there. So I should have even gone a little further. So now I'm going to plot my points. And when I go to plot my points, I have 0, 0. So no accident, no skid mark. And then I've got the point 5, 10. And remember, you want to label every couple points here. So that it's easy to read later. So now I have 5, 10, and then my last point was 20, 20. So start at 20 and go up to 20. Connect them, remember to keep it curved. Draw an arrow because it would continue to grow. So now you can actually find out. So if we were looking at this relationship here, the x values all had to deal with what? If you stop and think about it. The x values had to do with the length of the skid mark. So this is all our length of our skid mark. So at 0 miles per hour, the skid mark would be 0 in an accident. But then when we look up here at 10 miles per hour, the skid mark would be 5 feet. And when we look at 20 miles per hour, the skid mark would be 20 feet. But you can also look at other distances now that you didn't plug in. So at a 15-foot skid mark, a police officer can look at a chart like this and estimate that the person was going about 19 miles per hour. Or if a skid mark was 8 feet, then they can estimate that the person was going about 13 miles per hour. So a police officer who's investigating an accident can figure out approximate speeds based on skid marks using this formula. Okay, this is the end of lesson 10.5. In class we'll be working on the homework for this lesson, and make sure you ask me any questions you had during that time.